Alright, so I think this is the very last problem in your packet. It's like on the last sheet, very last problem. We're going to do it today as a warm-up. Just so you are aware, if you haven't looked back at the backboard, we have moved. Actually, it was up here too. We have moved the test from tomorrow to Friday. Okay? So your test is now on Friday. Works out better for me because I'm not here on Friday. So that's why we kind of moved it, and I don't have to worry about somebody teaching my classes. So there's that. So, but that then brings DECA people going to Intergalactics in Orlando into play because you're going to be gone on Friday. So we are full on recommending that you take the test tomorrow in class, and we'll give you time in class while everybody else is reviewing for the test. We'll give you time to take it in class tomorrow in the MRC. Okay? That's for those people who are going to be gone on Friday. Yeah. Okay. Go for it. Find me. What do we got to do? We got a Ferris wheel. You need to find me the equations. You got to find me your position. 2.5 minutes into the ride, and you got to tell me how long you've traveled on that Ferris wheel after riding on it for 2.5 minutes or for 4 minutes. Excuse me. So let's figure out what those struggles that you had were. Okay? So first off, I'm going to move this down here, and I'm going to move that down there, and then I'm going to say to myself, what is the x equation for this parametric? What is the x part of this parametric Ferris wheel? Most of you have this. What is the x equation for the parametric Ferris wheel?
40 cosine.
40. Why 40? So let's break that down first. Why 40?
The diameter is 80.
Because it said the diameter was 80, so the radius is 40. Cosine of what?
Negative pi e over a. Plus 3
So hold on
pi
1 second. Okay, so that we got from the period. So remember the period is equal to 2 pi over b. So b is going to equal 2 pi over the period, which is 2 pi over 16, because it took us 16 seconds to go around, which got me pi over 8. But why is it negative?
Because it's clockwise.
Because it said that we're going clockwise. So the pi over 8 comes from the period, the negative comes from the direction that we're traveling. Okay? Next.
plus 3 pi over 2.
I could go plus 3 pi over 2, or I could go minus pi over 2. Either one would work for me. Anything else in that line? Nope. Okay. Then we go y of t should be the same, except this changes to sine, correct? Okay. So that part's the same. This changes to sine. And then we have one additional thing at the end.
And 46.
Got to add 46 so I get it up off the ground. Otherwise, it's not going to be a very fun Ferris wheel ride if you're slamming into the ground. Okay. So plus 46 there. Okay. So now we can go to our calculators. Now, we're dealing with pi's and all that fun stuff, so we have to make sure that our calculator is in radians. Again, you can scroll up here to RAD. If it's in DEG, and just click on it, and it'll switch it over to radians. You want to graph this in radians. Okay? 40 trig cosine of negative pi, oops, got the break. Why is that going to give me a negative or an answer? Negative pi over 8, whoa, over 8. What I saw when I was going around, a lot of people forgot to put t in there, and I was reminding them, you got to have a variable at some point in time, plus 3 pi over, come on, over 2, be that one. Then I got this one. Oops, that's great. Then I got this one. 40 sine now of negative pi over 8. Why is it? Over 8. E plus I will go this way and make it 2, then plus 6. And what do I need to change my t-step value to be? Or my t value to be? Something bigger than 16, correct? Okay. Now, could I, because if we looked forward in the problem, it said we want to know what our position is 2.5 minutes into the ride, which would be 150 seconds. So I could go something bigger than 16, and I could go something like 200. Okay? And if I do that, I get this. Well, now I've just got to adjust my window. Over there, it's got to go at least to negative 50. Over here, it's got to go at least to positive 50. Up here, it's got to go at least to 86. Whoa, cut the brake. Come on. Okay. So, doesn't really look very circular. So what I can do is I can scroll on down here in the zoom, and I can get to the, I think it's B. Yep, B was zoom squared. And then I see the whole thing. Now, when I go to trace, I'm going to set my trace step at 0.5. Actually, I like because we got 16 seconds. That's okay. So then every 16 seconds around, it's gonna. So there we're loading. We're going in a clockwise manner. I'm using the keypad, but I'm just clicking to the right while I'm in the trace, and it shows the motion. We've got a 80-foot diameter Ferris wheel. We're going around once every 16 seconds. I know that because I get back to the bottom at t equals 16. We're 6 feet off the ground because my position is 0, 6 down there. And we're going in a clockwise direction. Yes, everything's good there. Now, to get that positioning at 150, I just literally click anywhere and I go 150, and there is the position that I'm at 2.5 minutes into the ride. I am 28.3 feet left of center, and we are 74.3 feet off the ground. Okay? If you didn't go all the way to 150, what would you use for 2.5 minutes? 6? Okay. Would it be 6? 16, 150. Okay, that's fine. I trust you. 150 divided by 16 would be 9 point, yep, 6. Yep, 6. Because it's 9 times around and then 6 more seconds. Okay? How far have we traveled after being on the ride for 4 minutes? Well, how long is 4 minutes in terms of seconds? 240 seconds, right? Divide that by 16 seconds to get how many revolutions that we have, which would be what, 50? 15? Okay. I was going to say 50 sounds way too much. Okay. 15 revolutions. Each revolution is a circumference of that circle. So the distance that we travel would be equal to, we went around 15 times. Each time we went around, it was 2 pi times 40 feet. So that's going to be 30 times 40. That's going to be 1,200 pi feet, which is approximately 3,769.91 feet, or 7/10 of a mile. Okay. Now, the second half of class today, what I'm going to do is, or what I would like to do is, I have 2 problems here for you and a shoulder partner to work on. Okay? Don't write on these. You have extra space in your notes packet to do this work. You've got the back side of the last page. Okay? So we were going to do a whiteboard. We were going to have you up at the whiteboards today. But then I'm like, it doesn't really pay to go to the whiteboards because the majority of your work is going to be done on the calculator. So we don't need to get to the whiteboard, so we don't have to go in groups of 3 or 4. We can go in groups of 2. Okay? So I'm just giving you get to work with the person sitting next to you because I only have a limited amount of these. So you might not get to work with who you want to work with, but you know what? Life isn't fair sometimes. Okay? What will happen then is I will be putting... I will put up the answers on the board because you got to know how to get to do the answers in order to okay, right?